In this one, let's take a look at several examples of adding and subtracting radical expressions. So we have here 5 times the square root of 5 plus 4 times the square root of 5. So here, the first step is to observe that the radical parts are the same. When the radical parts are the same, you basically add the coefficients. The coefficient is the 5 and the 4, the green values, the values in the green boxes. So we do it this way. You take the 5 and the 4 and you add them together. It's going to give you 9. And then you copy the radical one time, so it gives you root 5. So that's the square root of 5. In other words, 9 square root of 5. For example, imagine you have 6 root 5 plus, say, 11 root 5 minus 13 root 5. So here, because the root is the same for all the terms, you put it down one time, and then you just operate on the coefficients. So remember that that's the 6. The positive 11 and negative 13, you have to combine those. So when I do that, I have 6 and 11 here, and then minus 13. So 6 and 11 is 17. 17 minus 13 gives 4. So the answer is 4 root 5. In case you're in my class, answers like the 9 root 5, you might type in there simply by doing 9 and then SQRT, which is short for square root, and then 5. Make sure you put the 5 within the parentheses on the SQRT. Another example, it says add the following radical expressions where a is greater than 0. The fact that it says a is greater than 0 is not too important for our purposes. What is important is the following, though. Let's take a look. We have the root of 16a. So 16a under the root symbol plus 36a under the root symbol. And then here we have plus 100a all under the root symbol. So the first to be observed is that 16a, 36a, and 100a are all different. So you can't just add these and get some kind of composite one quantity. You need to make the root parts look the same. So you do that here in this case by taking and splitting the root symbol to each factor under each root symbol individually. That means it becomes this. The root of 16 times a under the root symbol plus the root of 36 times a plus 100 times a. So you distribute the root symbol to each factor individually. Then this becomes the following over here. The root of 16 is 4, so it's 4 root a plus 6 root a plus 10 root a. I'm just taking the roots, the square roots that is. And lastly, the coefficients, remember, are these values right here. And notice that it's just as important. You see how the square root parts are all the same now. So once you get to that point, after some work, obviously, you will have the following. You add up the coefficients. 4 and 6 and 10 is 20. And then you copy the root only one time, so it becomes the root of a. So the answer is 20 root a. And let's do last one. So that one looks like this. 7 under the root symbol 28x minus 9 under the root symbol 63x. That's fine. So let me pull this down. It's going to look like the following. Right now, what you need to observe is that 28x and 63x are clearly different expressions. So you can't just combine this by doing 7 minus 9. You need to make the expressions under the root symbols look the same every time. So for that reason, I'm going to do it this way. I'm going to say 7. And I'm going to try to rewrite the 28 so that it shows a perfect square factor. But it's really the largest perfect square factor always that you can find. Okay, so in this case, 28, that has 4 times 7 times x, because 4 times 7 is 28. But for the other one, well, you've got 63. You can rewrite that, for example, as 9 times 7 times x. And I know that I'm on the right track for the following reason. This matches here and here. If you don't get the portions, for example, like 7x and 7x matching, that means you probably want to try to rewrite it a bit differently. And also you want to make sure that under the root symbol, the way this is designed is that you have perfect squares at least once. Okay? So 4 is a perfect square, 9 is a perfect square. Once you've got it in that position, then you have the following. 7, you distribute the root symbol to each factor individually, so 7x here and the 4 minus 9, and then this is now square root of 9 times the square root of 7x. At this point, you take square roots, so it becomes 7 times 2. 7 times 2. Remember, the square root of 4 is 2. Then you copy the 7x portion, minus 9. The root of 9 you bring down as just 3. You copy the root 7x. Step 4, you multiply. So 7 times 2 now is 14 times 7x minus 27 times 7x. Do the multiplications next. Lastly, You work on the coefficients. Remember, the coefficients are the 14 and the 27 negative. So you get as 14 minus 27 is negative 13. And then you copy the root part one time, so it becomes 7x. And that's it. That solves the whole problem. Thanks.